My name is Brenda Banwell. I'm a clinical researcher at the Hospital for Sick Children and a pediatric neurologist. And I've had the privilege of serving as the Clinical Research Task Force Chair. And in that capacity, I had the ability to interview a lot of people who do clinical research, to talk to families, to talk to children, and to understand the role of research at the Hospital for Sick Children. I think the most important thing that I want to share with people is the value of clinical research for the people living with the disease, but also for the healthy controls who come and give a little of their time and a lot of themselves to this hospital. Clinical research is what helps us understand what's going well in the human body and what's going wrong. In the terms of MRI scans, the image of the brain, which is what I study, is enhanced by our understanding of what normal brain imaging looks like, what normal brain growth looks like, and what happens when the brain is not healthy. If we didn't have healthy children to help us understand those changes, we would never be able to figure out what went wrong. Healthy children guide the care of children who are less fortunate. Volunteering for research at the Hospital for Sick Children is an incredibly valuable experience. When we asked kids who they told about clinical research volunteerism, the kids that volunteered at the Hospital for Sick Children told everybody. They told their parents, they told their grandparents, they told their coach, they told their classmates, their parents told their other people at work, the grandparents told their neighbors, and an entire community was proud of the child that came and gave their day to help other kids who are less likely to have a normal childhood, who have kids who miss school, who miss dance, who miss swimming, who miss all the things that other healthy children take for granted. The Hospital for Sick Children is a really important part of our community, and the healthy controls are a key part of what makes us do what we do well.
This is a magnetic resonance imaging machine. MRI works in a really interesting way. It's actually a big, huge radio.
When the body goes into the scanner, the hydrogen molecules align or anti-align with the magnetic field. When hydrogen aligns with the magnetic field, they spin like a top, and we send in a radio frequency pulse, just like the radio in your car, and knock over the hydrogen, just like bowling, except we can control the direction that they fall. And when they come back to their original state, aligning with the magnetic field, they release an energy. And this is the energy that helps produce the MR image.
Okay, so Jake, everything's fine. Take a breath in and hold it, don't breathe.
I work in a field called exercise medicine. We study how exercise intolerance is created in chronic diseases. Why children with chronic diseases have such a hard time exercising. We look at things like how the heart works, how the lungs work, how the muscles work, and how we can use exercise to treat and even prevent chronic diseases from happening. This is really important work, and we use things like MRI and actually a bike that goes into the MRI that allows us to exercise while we're in the magnet. That allows us to take pictures of the inside of the body, of the heart, of the lungs, of the muscles, and to see how the body's working. This is one of the things we really need people to come in and take part and do, because when we can contrast healthy people with children with chronic diseases, we can learn a lot about how the body works and how it doesn't work. So if you can help us out, that'd be absolutely fantastic.
I'm Jane Schneiderman, and I'm an exercise physiologist in our Exercise Medicine Research Lab here at the Physiological Research Unit in the Hospital for Sick Children. We conduct research on children with various chronic diseases, and we have a real need for children who are healthy without disease so that we can compare their values to the children that come through our lab with disease, and so we can know how well or not well they are. So there are many reasons why kids are sent to our lab to be measured for their physicians. Sometimes it's to help us to diagnose a disease. Sometimes it's to measure them before a particular treatment, so we'll measure them before and after that treatment to see their progress. And there are many different types of measurements that we make. One of them is something called your aerobic fitness, and it's probably the best overall measure of someone's fitness is their aerobic power, or their maximal aerobic power. And that's what I'm going to show you now. Okay, so here we have someone who's riding the bike for us, and she's breathing through a mouthpiece, and we're measuring her oxygen consumption and her carbon dioxide production, and we're watching her heart rate and how difficult it is as she climbs the hill on this bike. We're also going to do measurements of her blood pressure, as well as we're measuring her oxygen saturation with a little probe that is on her forehead. And eventually she just won't be able to do any more after trying her very hardest, and that will be her maximal aerobic power.
My name is Lars Kosovortman, and I'm one of the cardiologists here at SickKids. I also work in diagnostic imaging, and one of my main research interests is around cardiac MRI, or magnetic resonance imaging, in children with heart problems. In one of my research projects, I use MRI to look at the hearts of children after heart transplantation. These are children who were either born with a severe heart problem or whose hearts grew so weak over time that they needed a new heart. Sometimes, after transplantation, their bodies try to attack the heart that was transplanted. This is a process that's called rejection. Transplant rejection is a serious condition that must be treated. Often we actually have to examine a small piece of the heart muscle under the microscope to be certain whether rejection is happening or not. We call this procedure a biopsy. And even though it's done while the patient is asleep most of the time, it's of course not a very pleasant procedure for anyone. That's why it would be great if we could find some other way to diagnose rejection. This is where MRI comes in. I think that MRI might be able to detect rejection or rule it out without having to perform biopsies, but just by taking pictures of the heart. For this and many other studies, it is very important for us to examine also children and teenagers without heart conditions. And that's exactly what we do. If they agree to participate in the study, we will invite them to undergo an MRI scan. We hope that using MRI in the future we'll be able to get rid of all, and if not some of the biopsies that we currently have to do in kids after heart transplantation.
My name is Peter Church. I'm a GI fellow here at SickKids, and I study Crohn's disease, which is an inflammatory bowel disease where the gastrointestinal tract becomes inflamed and over time actually becomes damaged. And the study that we're working with is called ImageKids, which is a study where we're using MRI to quantify and actually measure how much inflammation and damage there is in the gastrointestinal tract. So what we're doing is we're asking children who have Crohn's disease that are old enough to have an MRI done to really do nothing more than what they would normally have done as part of regular clinical care. They'll have MRIs of their gastrointestinal tracts, of their esophagus, their stomach, their small bowel, their large bowel, and we'll take that information and match it up with other clinical information that we would collect routinely anyway. And hopefully, through that process, we'll have a better idea of how to quantify inflammation and damage on their MRIs.
Hi, I'm Dr. Seed, and here we are in the corridor of the Cardiac Diagnostic and Interventions Unit, and this is where we do research MRI scans. And my research project is doing MRI scans on babies that haven't even been born yet. The reason we're doing that is because we want to measure how the blood goes around the baby and see how the oxygen goes from the mum to the baby. Using the MRI scan, we can make a 3D picture of the baby, just like this one, which shows it lying in the mummy's womb. Here's another MRI picture of someone's heart, and here you can see the blood flow as it gets pumped out of the heart through the aorta and pulmonary artery. So the MRI scans we do help us make diagrams like this, which show the blood flow flowing around the fetal circulation. The numbers in the circles represent blood flow measurements, and the colours represent the colour coding for oxygen saturations. So first of all, we need to know what the normal distribution of blood flow in the body, and that's why we've been enrolling normal volunteers to have their scans, so we can know exactly what the normal blood flow should be, and then start to understand what the abnormal blood flow might be and why.
My name is Dr. Elizabeth Donner, and I'm a neurologist here at SickKids. And one of the things that I do is I take care of children with epilepsy. Epilepsy is a condition in which people have seizures. Some people with epilepsy have only seizures, and some people with epilepsy have other challenges like problems with learning or moving. And one of the things that we do in my research lab is we take brain pictures of people with epilepsy to try and figure out how we can best do surgery or an operation to cure them of their seizures. In our lab, we use something called functional MRI to figure out which part of the brain is involved with things like talking, reading, and using language. And the purpose of that is to figure out where in the brain is the language center, so that when we do operations to help people to get rid of their seizures, when we do brain surgery for epilepsy, we can take out the part of the brain that's causing the seizures, but leave behind the part of the brain that's necessary for talking and reading and using words. Functional MRI is different from typical or usual MRI. In a typical MRI, we just take a picture of your brain so we can see what it looks like, and it's a black and white picture. In functional MRI, we actually are able to have the person lie down in the MRI machine and do something for us, like look at words or move their fingers. And the part of the brain that controls your finger movements will actually light up using functional MRI. The way that works is we're taking pictures of where the blood flow is increased during the task. So when I do this, the part of my brain that controls my right hand, which is right about here, has more blood going to it. And I can take pictures of that using functional MRI and get these really nice images with red and orange and blue and yellow showing me the areas that control my hand.
I'm Dr. Margot Taylor, and I'm a scientist at SickKids, and I look at brain function and brain imaging, so I'm a neuroimager. And we're very interested in the changes in the brain with child's development and how the brain helps the child think. And we use the MRI for a number of different types of studies. And so the MRI gives pictures of the brain that allow us to see how the brain is growing, and that growth affects how well children think and how well children can do things like memory tasks or puzzles. And when a child is thinking, certain parts of the brain need more blood supply, and that increase in blood supply also lets us do functional MRI. It's called fMRI, and that lets us see which parts of the brain are most active for different types of tasks. And so we're doing a number of different types of studies, and we're looking at things such as memory, at planning tasks, and emotional face processing. And these types of tasks use a lot of the brain, but particularly the frontal lobes of the brain. Within the brain, there are all the fiber tracts. It's like the highways of the brain. And we can also take pictures of those with a certain type of imaging on the MRI. And this shows you a picture of the different highways in the brain on a child's brain. And you can see that the different colors represent different types of highways, pathways in the brain, and the colors that you see on this image represent different directions. So the ones that are blue are going up and down vertically in the brain, ones that are green are going from the front of the brain to the back of the brain, and ones that are red are going from the left side of the brain to the right side of the brain, or vice versa, of course. And so we are also studying these functions and these abilities in children who are normally developing, to be able to compare them to children who have difficulties with some of these typical abilities.
Children who volunteer for MRI research will come in, lie on the MRI table. It takes about 40 to 45 minutes for most studies. And at the end of that, we will have a very fancy picture to compare to the children with other medical problems, and in that comparison, learn what is going well and what isn't. The MRI scan does not involve x-rays. It does not involve any danger to the patient, and at the end of the MRI, you won't feel any different than you did beforehand. You will, however, be proud of having contributed to research at the Hospital for Sick Children.